Yeah, good evening, everyone. Am I audible? So we have completed all the concepts except optical instruments, right? Last class, I remember doing problems based on prism. No. Shall we start with optical instruments? Am I audible? Can someone respond?
Yes, sir.
Okay. So we'll get started with simple microscope, right? So for a simple microscope, for every optical instrument, we have two formulae for magnification. One is when the image is formed at the least distance of distinction, or we call it as near point, right? And the second is when it is formed at infinity, which is the far point, right? In a similar case, for a simple microscope, the magnifying power of it is given as 1 plus d divided by f, where d stands for the least distance of distinction and f obviously stands for the focal length, right? Whereas when the image is formed at infinity, that one is lost, so you have the magnification as d divided by f, and for capital D, we take the value as 25 for normal I, unless and until it is mentioned in the question, right? So having said this, we'll get started with the first problem. So there is a thin convex lens of focal length 5 centimeter, which is used as a simple microscope with a person with a normal near point of 25 centimeter. What is the magnifying power of the microscope? So M is equal to 1 plus capital D divided by F. So this is equal to 1 plus, what is the value of capital D? It is 25. This 1 plus 25 divided by F is going to be 5. So answer will be 6. Here, if you observe, for capital D, I didn't use minus 25 centimeter because this is already applied during the derivation, and this is a specific formula for, what is it? There's a specific formula for the simple microscope. So we need not use any sign convention. That is a point to be noted here. Okay. Is the point clear? So it is a simple problem. Next. So tell me how to do this. An object is to be seen through a simple microscope of power 10 diopter. Where should the object be placed so as to produce maximum angular magnification? And the least distance of distinction in this case is 25 centimeters. So how to solve this problem? So how to solve this problem? So read the question carefully. An object is to be seen through a simple microscope of power 10 diopter. Plus 10 diopter means obviously it is going to be a convex lens. So what is going to be the focal length? So focal length is going to be 1 divided by 10, which is going to be 10 centimeter, right? where should the object be placed? So U is equal to what? So as to produce maximum angular magnification. For you to produce maximum angular magnification, the image should be formed at the least distance of distinction. So V should be minus 25 centimeter, because a simple microscope will always form a virtual image. Virtual image will have the object and the image on the same side. So applying the formula 1 by V minus 1 by U is equal to 1 by F implies 1 by minus 25 minus 1 by U is equal to 1 divided by 10. So what will be the value of U? 1 by U will be equal to 1 minus 1 by 25 minus 1 by 10 minus 35 divided by 250. So U is equal to minus 250 divided by 35. So how much is it going to be? It is minus 50 divided by 7. Minus 7 point something will come. So object should be placed there. Okay, let's do the next one. Listen. How to solve this? So a converging lens of focal length 6.25 centimeter is used as a magnifying glass. Magnifying glass is basically a simple microscope. If the near point of the observer is 25 centimeter from the eye and the lens is held close to the eye, calculate the distance of the object from the lens. So U is equal to what? Second is calculate the angular magnification. And the third part is calculate the angular magnification when the object is when the image is formed at infinity. Here is when the object is formed at D. So how to find U? 1 by V minus 1 by U is equal to 1 divided by F. So which implies 1 divided by minus 25. So here if you observe, I am applying sign convention in the lens formula, but I am not applying the sign convention in the magnification formula. Okay, so minus 1 by 25 minus 1 divided by U is equal to 1 divided by 6.25. 6.25. So 6.25 can multiply and divide with 4, so that you will get 4 divided by 25. So 1 by U minus 1 by U is equal to 1 by 25 plus 4 divided by 25, or it is going to be 5 divided by 25. So U will be equal to minus 5 centimeter. This is where the object is to be placed. So calculating the value of magnification in the second case, we will get M is equal to 1 plus D divided by F. So it is going to be 1 plus capital D is how much? 25 divided by F is 6.25. So it will be 1 plus 25 into 4 divided by 25. This and this will get cancelled. So 5 will be the magnification. Similarly, when the image is formed at infinity, M will be equal to D divided by F. 25 divided by 6.25. Answer will be 4. 5 minus 1 is going to be 4. Okay. Next, we'll see some problems based on compound microscope. See, magnifying power for a compound microscope is given as the product of magnification of the objective and the eyepiece. Okay. Now see, when the final image is formed at the least distance of distinction, magnification due to a compound microscope is given as V naught divided by U naught into 1 plus D divided by FE, or it is also given as minus L divided by F naught into 1 plus D by Fe, where L is called as the tube length. So write down these formulas. So magnification when the image is formed at the near point is given as V naught divided by U naught into 1 plus D divided by Fe. Okay. Or it is also minus L divided by F naught into 1 plus D divided by Fe. Similarly, when the image is formed at infinity, M is given as V naught divided by U naught into D by Fe, or minus L divided by F naught into D divided by Fe. Now, so you are given two converging lenses of focal lengths, 1.25 centimeter, that is 5 by 4 centimeter and 5 centimeter, to design a compound microscope. If it is desired to have a magnification of 30, find out the separation between the objective and the eyepiece. So F naught is for whom? It is for, sorry, F naught is the focal length of the objective and its value is going to be 1.25 centimeter or 5 divided by 4 centimeter. Similarly, Fe is going to be equal to 5 centimeter. Right? Now, if you are expecting a magnification of 30, find out the separation between the objective and the eyepiece. Okay. So what formula are you going to apply? M will be equal to L divided by F naught into 1 plus D divided by Fe. So M will be equal to, magnification is how much? You need to produce a magnification of 30. So since it's a virtual image, magnification is taken to be positive. It is equal to L divided by, what is the value of F naught? It is 1.25, which is 5 divided by 4 into 1 plus D is 25 divided by Fe is going to be 5. This and this will get cancelled to be 5, which implies, so this whole thing is 6. 6 will cancel this 30 5 times. So that implies L is equal to 25 by 4 centimeter. So 25 by 4 is going to be 6.25, right? Yeah. So it is 6.25 centimeter. So make a note of this.
Sir, I have a doubt, sir.
Tell me that.
Sir, generally, we consider tube length as distance between the two lenses kept, sir.
Yes, it is between the optical centers of them. Yes. That is what is, see, there is actually an approximated formula. V naught divided by U naught regular. V naught divided by U naught into 1 plus D by Fe is the actual formula. There we approximate this V naught. So what we do is 1 by V minus 1 by U is equal to 1 by F length, we derive it. On multiplying everything, see 1 by V naught minus 1 by U naught is 1 by F naught. So multiplying both the sides with V naught, right? What will you get? V naught by V naught minus V naught divided by U naught is equal to V naught divided by F naught. So this will become 1. So minus V naught divided by U naught is equal to, or I'll take V naught by U naught is equal to 1 minus V naught divided by F naught. Okay, since this is going to give you the magnification, so since this is going to give you the magnification, right? Since they are assuming it to be greater than 1, this 1 is ignored and this can be written as minus L divided by F naught. That is why you're writing this. Actually, again, Vardhana magnification, it is written as M naught, which is V naught divided by U naught. And the V naught divided by U naught is what is approximately equal to minus L divided by F naught. That L is taken to be the distance between the two lenses. அதுக்கு பேர் தான் என்னது? You call it as tube length. So basically,
Sir,
this problem, they asked you what is tube length. Tell me.
sir, does this change when it's formed in infinity?
Yes, it will. No, it will change. No, because see, formula is changing. No, unnalda first see basically the idea of compound microscope. Here you have objective. Here you have an eyepiece. Am I right? So here you have an object. What is the objective of a compound microscope? To magnify this object multifolds and show it to you. So for this, the first image will be formed here. Okay. It will be a real and inverted image. If in the distance V0 and how much is this distance? U0. Purida. So what is the magnification produced due to the objective? It is V0 divided by U0. Accepted. Correct?
Yes, sir.
Okay. Similarly, this object, this image formed due to the objective will act as the object for the eyepiece, so that you get a virtual image which is magnified, so that it is formed at the least distance of distinction. Purida. Then this eyepiece is actually acting like a simple microscope for this object. So what is the magnification produced due to a simple microscope? It is 1 plus d divided by Fe when the image is formed at least distance of distinction, whereas it is d divided by Fe when the image is formed at infinity. Right? So since we are using two lens combination, whenever two lenses are used in combination, the resultant magnification will be the multiplication of magnification produced due to each image. Are you able to understand what I'm trying to say?
Yes, sir.
So this one will change, but V0 by U0 is still the same. So that is why you have two formulae. Now I hope you can understand and make a note of it. Purida.
Yes, sir. Sir, I have another doubt, sir.
Tell me.
Generally, if there's like combination of like lenses, then magnification is like multiplication of the each lenses,
Yes.
sir.
Yes, yes. See, if you have a doubt because of that, I'll tell you why. This I discussed in power of lens. See, what will happen is, okay, let me take something like this. Two lenses are in contact next to. Okay, here is where the object is placed. Let's say this is U. Okay, this is U. Let this be V1 and let this be V. Okay. So what will happen? This first lens, this second lens. What is the magnification produced due to the first lens? V1 is the image formed due to the refraction taking place from the first lens. So M1, can I write it as V1 divided by U1? Sorry, V1 divided by U. Kaushik, are you there? M2 and what will I write? I will write it as V divided by V1. Image formed due to the first lens will act as the object for the second lens. That is the only principle.
Yes, sir.
If I replace these two lenses with one particular lens whose magnification is M effective, then either object distance or this will be image distance. M effective V divided by U.
Yes, sir.
Correct? If I observe M1 and M2, if I multiply, so or M effective V by U, can I write it as V by V1 into V1 by U, multiplying dividing with V1. V by V1 will be what? M2. V1 by U will be M1. So is it not the product of both?
Yes, sir.
Got it? Got the idea? So whenever two lenses are used in a combination, the resultant magnification is always the product of the magnification produced due to individual lenses. Purida. So
yes,
having
yes.
said this, yes. Can we do another problem? Having said this, see, draw a neat label diagram of compound microscope showing the formation of the image at the near point of the eye. All those things you do. Second, A compound microscope uses an objective lens of focal length 4 centimeter and focal length of eyepiece is 10 centimeter. An object is placed at a distance of 6 centimeter from the objective lens. Calculate the magnifying power of the compound microscope. The final image is formed at the near point. So M will be equal to V naught divided by U naught into 1 plus D divided by FE. What is it? We don't know in this problem. In this formula, all data we have. D over 25, because they told near point. FE is known, D is known, U naught is known, V naught is not known. So what we'll do is we'll use the lens formula. 1 by V naught minus 1 by U naught is 1 by F naught. So 1 by V naught minus 1 by U naught minus 6 is equal to 1 by F naught 4. So 1 by V naught will be equal to 1 by 4 minus 1 by 6. So 6 minus 4 divided by 24. 2 divided by 24 and V naught will be 12 centimeter. Take this and substitute it here. Answer will be 12 divided by minus 6, right, into 1 plus D divided by FE. 25 divided by 10. 2 into 2.5, 3.5. Answer will be minus 7. No units. Right. So since this is a case specific problem, you need not put the minus sign because it is already applied while you're deriving it. So I hope by now you would have understood where to use sign convention and where not to use sign convention. So this is answer for magnifying power. Calculate the length of the compound microscope. So length, how will you calculate that? L is equal to M is equal to L divided by F naught into 1 plus D by FE. So 1 plus D by FE is 3.5. So this will cancel this 2. So 2 is equal to L divided by F naught, which implies L is equal to 2 into F naught. F naught is 4. So 8 centimeter will be the distance between them. Okay. This one is an approximated one. See, listen. Calculate the length of the simple microscope, compound microscope. So this is where the object is placed at a distance of how much value? 6 centimeter. And the image is formed at 12 centimeter. Right. Now, where is the final image formed with respect to the eyepiece? It is formed at a distance of 25 centimeter. So can I say this distance is equal to UE and this is V naught? So if you calculate the length, the distance between these 2 points, then that is going to give you the length of this compound microscope, right? So for that, what we can do is, so we know V naught is 12. So to calculate UE, we'll apply the formula 1 by VE minus 1 by UE is equal to 1 by FE. So 1 by, what is the value of VE? It is minus 25 is equal to minus 1 by UE is equal to 1 by FE is 1 by 10. So 1 by UE is equal to minus 1 by 25 minus 1 by 10, or it is minus 35 divided by 250. This is 1 by UE. So UE will be equal to 250 divided by 35, which will be approximately 7 point something. 7.1, I think. Yeah, 7.1 centimeter. So distance will be equal to magnitude of V naught plus magnitude of UE. So V naught plus UE is going to be the distance. V naught is 12. UE is 7.1. So answer should be 19.1 centimeter. So one last problem based on compound microscope is the total magnification produced by a compound microscope is 20, while that produced by the eyepiece alone is 5. When the microscope is focused on a certain object, the distance between the objective and the eyepiece is found to be 14 centimeter. Find the focal length of the objective and eyepiece if the distance of distinction is 20 centimeters. So he has a defective eye. Okay. So total magnification is 20 means what? So magnification is given as 20. Magnification produced with the eyepiece is 5. Least distance of distinct vision is 20 centimeter, and VE is how much? The distance between the objective and the eyepiece is found to be 14. So VE, see D is 20 centimeter, then VE will be minus 20 centimeter. Right. So we know that M is equal to M naught into ME. So they asked what is the so we need to find the magnification produced due to the objective, which is given as M divided by ME. M is how much? 20 divided by ME is how much? 5, which will give you a 4. Right. Now, we can find the focal length of the objective using the formula ME is equal to 1 plus D divided by FE, because eyepiece is acting like a simple microscope. So 1 plus D is 20 divided by FE is going to be how much? That is what we need to find. And magnification produced with the eyepiece is 4. So 3 is equal to 20 divided by FE.
Eyepiece
So
5, sir.
Edra?
Eyepiece magnification 5, sir.
Eyepiece 5. Oh, sorry. Is magnification due to objective either 5. Okay. If this is 5, then how much will you get here? 4 varda. So FE should be equal to 5 centimeters. So focal length of the eyepiece is 5 centimeter. So focal length of objective should be less than this. Next. Now what did they ask? Distance between objective and eyepiece is 14. Distance between objective and eyepiece is 14. So V naught plus magnification of UE is equal to 14. So V naught evlo? V naught, we don't know. So V naught, we don't know. What is the value of UE? UE also we don't know. So to calculate UE, what we will do is 1 by VE minus 1 by UE is equal to 1 by FE is what we are going to apply. So 1 by VE minus 120 minus 1 divided by UE is equal to what is the value of 1 divided by FE is how much? FE is 5. So 1 divided by UE is equal to minus 1 by 20 minus 1 by 5. Minus 25 divided by 100 is 1 by UE. So UE will be equal to minus 4 centimeter. So V naught plus this is going to be 4 is equal to 14. So V naught will be 10 centimeter. Since we know V naught and F naught, sorry, V naught and U naught, V naught is known. So magnification of objective is V naught divided by U naught, which implies what is the magnification of objective? 4. 4 is equal to V naught is 10 divided by U naught. So U naught is how much? 2.5 centimeter. Right. Only difference is here V naught. Okay. I need the focal length. No, find the focal length of the objective. To find the focal length of the objective, 1 by V naught minus 1 by U naught is equal to 1 by F naught. So two unknowns are there. So U naught should be I'll multiply this with V naught. 1 minus V naught divided by U naught is equal to V naught divided by F naught. So V naught, can I take this to the left and this to the right? This implies 1 minus V naught divided by F naught is equal to V naught divided by U naught. And this is going to be the magnification of the objective. So 1 minus 10 divided by F naught is equal to, what is the value of magnification produced due to the objective? It is 4. So 4, which implies 1 minus 4 is equal to 10 divided by F naught. So F naught will be equal to 10 divided by minus 3. Correct? Magnification due to the objective, we got it as 4 or minus 4. Huh? Okay, the answer is given as 2 centimeter. So listen, 1 minus V naught divided by F naught, or I can say V naught divided by F naught is equal to 1 minus M naught, which implies V naught is 10, no doubt in that, because it is on the right. What is the value of F naught? That is what we need to calculate. 1 minus, see, what is the value of magnification produced due to the objective? It produces a real and an inverted image. So for this, the magnification should be taken as minus 4. Right, this will be 5. This will be 10 divided by F naught. So F naught will be equal to 2 centimeter. Why the previous one was wrong? Let's see. If I do without sign convention, you are getting V naught divided by F naught is equal to 1 minus M naught. So you're getting 1 minus 4, which is minus 3. Means focal length will come out to be negative, which is wrong for a convex lens. Okay, this is where I got the mistake in mind. See, this is actually a tough problem only. I'll explain the algorithm. See, the total magnification is given, means if you need to calculate the effective magnification due to a compound microscope, it is going to be 20, right? Of which the magnification produced due to the eyepiece is 5. So will you be able to calculate the magnification due to the objective? Yes, by using this mathematical expression. Okay, I used it. Then I got it as 4, right? 1 minute. Sorry. So this microscope is focused on a certain object such that the distance between the objective and the eyepiece becomes 14. Means V0 plus magnitude of UE is equal to 14. Right. Now our interest is to calculate the focal length of the objective and the eyepiece. And remember, whenever a problem is based on you calculating the focal length, then we need to use the lens formula. So that is why if you see, I had used the lens formula. Right. So I started using the lens formula in both the scenarios. And then I solved it. So there are only two methods in which you can solve. See, one is if there is one unknown and magnification is given and you know where the image is formed, you want to find the unknown, that is a focal length, you can use magnification formula. But if there are certain distances other than the focal length that is getting involved, then you need to use the lens formula and then proceed. Okay, that is the logic. Is it clear? Okay. Now we will start with ray optics. Sorry, wave optics.
Sir, I have a last doubt, sir.
Tell me now.
Sir, while reporting the answer for magnification, should we just show the magnitude or even the sign, sir?
Magnitude is enough. When you're reporting, that is enough. When you're using it in the formula, right? That time you see. That time you need to use plus or minus.
Yes, sir.
For example, when you talk about a compound microscope, magnification of the objective will actually be negative. Magnification of eyepiece will be positive. So that is the meaning, right? For negative, magnification due to a lens being negative is a real and an inverted image, whereas a magnification being positive is a virtual image. Here.
Yes.
So we'll do some problems that are based on wave optics. See, wave optics again has a connection from the previous chapter, right? So in this, if you see, you know what is Snell's law, you know how to write the refractive index. Speed of light in vacuum is given as lambda multiplied with frequency. Similarly, the refractive index is given as the wavelength in vacuum divided by the wavelength in medium, right? Based on which you can rearrange and write it. Optical path is not a part of your syllabus. We need not worry about. Next is frequency of light remains unchanged during the refraction and reflection part. Why is it so? Because light is the characteristic of source producing it. Okay. Let's try this problem. Monochromatic light of wavelength 600 nanometer is incident from air on glass surface. What are the wavelength, frequency, and speed of the refracted light? The refractive index of glass is taken to be 1.5. So how to solve this? 1.5 will be equal to, observe. How is the refractive index defined as? It is the wavelength in vacuum divided by the wavelength in the given medium. So 1.5 will be equal to lambda in vacuum divided by the lambda in the medium, which implies 1.5 is equal to, what is the value of lambda in vacuum? 600 into 10 power minus 9 divided by the lambda in medium is going to be how much? See, 1.5 will cancel 600 how many times? 400 times. Which implies lambda m will be equal to 400 into 10 power minus 9 meter, or it is going to be 400 nanometer. frequency. So how to calculate the frequency? Frequency is equal to speed into lambda. Sorry. C multiplied with lambda. C is 3 into 10 power 8 divided by lambda is 600 into 10 power minus 9. This will go 200 times. So 10 power 8 divided by 2 into 10 power minus 7. 10 power 15 by 2 or 0.5 into 10 power 15, which is also equal to 5 into 10 power 14 hertz. That is the frequency in both the media. Because frequency does not change when the light travels from one medium to another. Now, what about the speed? So we know that mu is equal to speed in vacuum, that is C, divided by Vm. So 1.5 is equal to 3 into 10 power 8 divided by Vm. This goes 2 times. So the speed in the medium is given as 2 into 10 power 8 meter per second. The refractive index of diamond is 2.47 and the refractive index of the window glass is 1.51. How faster does light travel in window glass than in diamond? So refractive index of window glass divided by refractive index of diamond is equal to speed of the light in diamond divided by the speed of the light in the window glass. So that implies VW divided by VD is equal to mu D divided by mu W. Mu D is 2.47 divided by 1.51. So the speed in window is equal to 2.47 divided by 1.51 is obviously going to be greater than 1 but less than 2. It will be 1.63 times greater than the speed in the diamond. See, these are all similar kind of problems. I would like to concentrate on the concept of amplitude and intensity, this one. Interference based problem. Okay. So listen. Listen. So when two waves of amplitude A1 and A2 with a phase difference of 5 are going to overlap on each other, then the resultant amplitude is given as root of a1 square plus a2 square plus 2 times a1 a2 cos phi, and the resultant intensity is given as I1 plus I2 plus 2 root of I1 I2 cos phi, right? If I1 is equal to I2 and we take it as I0, then the resultant intensity is given as 2 times I0 into 1 plus cos phi, or this is also equal to 4 times I0 cos square phi by 2. This is a very, very, very important condition. Okay. So we are going to see problems which are based only on this concept. Let us solve 2 to 3 problems for today. See, listen. There are two plane monochromatic waves propagating in the same direction with amplitude A. So A1 is capital A and A2 is 2A, and the phase difference is going to be pi by 3. Calculate the amplitude of the resultant wave. A will be equal to root of A1 square plus A2 square plus 2A1 A2 cos phi. So root of A square plus 4A square plus 2 times A into 2A into cos pi by 3. See, cos pi by 3 and 2 will get cancelled. It will be root of A square plus 4A square plus 4A square, which is root of 9A square, which will give you 3A. So this is going to be the amplitude of the resultant wave. So I hope it is clear. Okay. Now, two sources of intensity I and 4I are used in an interference experiment. Find the intensity at points where the waves from the two sources superpose with a phase difference of 0, pi by 2 and pi. Okay. So shall we do the first one? Tell me the formula. Intensity of the resultant is equal to I1 plus I2 plus 2 times root of I1 I2 cos phi. What is the value of I1? I. What is the value of I2? It is 4I plus 2 times root of I into 4I into cos 0 degrees. So how much will be the answer? 4I plus 4I, 5I plus 4I, which is going to give us 9I. Second, phase difference of pi by 2. So I will be equal to I1 plus I2 plus 2 root of I1 I2 cos pi by 2. So this will be a 0. So I1 plus I2 will be 5I. Third, when the phase difference is pi, so I will be equal to I1 plus I2 plus 2 root of I1 I2 cos pi. So I1 is I, this is 4I plus what is going to be the value of cos pi? It is minus 1. So 4I and 4I are lost. Answer will be I. So that is how you solve problems, right? So I hope you could understand this. Yes or no? Is this clear? Okay. So we'll do the one last problem and wind up. Okay, this fringes and all, I need to explain the concept in detail. Okay, we'll do one thing. We'll stop with this for today. And tomorrow's class, I'll start from this problem. Okay, any other doubt? See, is there any concept from wave optics which you want me to explain? 1 minute. Okay. So is there any concept from wave optics that you want me to explain? All are clear?
Sir, I have a request, sir.
Mm-hmm.
Can you like revise the diffraction part, sir, about the formula? It was like slightly confusing, sir.
Okay, I'll do one thing. See, see in this, no? So in this videos part, right? In the pre-recorded one, in theory in wave optics chapter, right? This is how I put videos. I know this chapter is tough. So this one, can you go through the, this lecture 15, right? 15, 16, and 15, 16, 17, 18 are there, no? Kaushik, there.
Ah, yes,
You're
sir.
with 15, 16, 17, 18 alone. Can you try to go through them before tomorrow's class? Because
Yes, sir.
see, you see the amount of time I've taken to explain them, 22, 30 minutes. Really, we need 1 more hour to discuss that topic itself. So if you go
Sir,
through that, uh-huh.
I don't know the exact explanation of the topic, sir. I had just a doubt in the particular formula, sir. Where I should use it. That's what
I would suggest one thing, that it is only like 45 minutes of time total, right? I would suggest you go through everything in detail because I'll explain completely in detail. Hopefully, your doubt will get clarified. You go through that in tomorrow's class. What we'll do is you ask that specific doubt. Okay, I'm assuming that you get cleared in the videos itself. If you're still not clear, I'll definitely explain. Will that work?
Okay, sir.
Yeah, yeah. But
Yes.
please go through the video and come. It will be clear.
Yes, sir.
Because I've shown some experimental stuff also there. You'll understand why that pattern is actually coming. Because see, I understand double slit means you have 2 slits, you're going to add base, but here everything is theoretically, we are giving an explanation to it. Why is it so? I have explained it. Okay, go through it. So that's it, guys. That's it from my side. We can wind up.
Thank you, sir.
Thank you, sir.